I'm Donghao Shao from Nanjing University of Aeronautics and Astronautics. I'm really appreciated to have the opportunity to share my work here. As an excellent climber in nature, Gecko has attracted many researchers' attention due to its extraordinary moving ability on non-structural or obstacle terrains. This kind of locomotion adaptability is mainly related with its adhesive features and selector system. So we develop a gecko-like robot with adhesive features and body height adaptability through the analysis of the real gecko system. Firstly, let's look into Section 2, Gecko-inspired robot. The whole physical Gecko-inspired robot is primarily consists of two key parts: the biomechanic leg and hybrid soft-rigid adhesive foot. The leg structure of Gecko-inspired robot is learned from the joint configuration of real gecko. Joint 1, joint 2, and joint 3 make up the shoulder joint, which is similar to the gecko's shoulder with 3 degrees of freedom. Joint 4, with 1 degree of freedom, corresponds to the gecko's elbow joint. 3 passive degrees of freedom were added in waist joint. Single leg shares 7 degrees of freedom in total, which makes the adjustable body height possible in mechanical structure. The hybrid soft-rigid foot attributes the adhesive features to the robot. Comparing with the foot of real gecko, the different parts of robot foot share the distinct functions. The rigid part for accurate movement generation, the soft part for absorbing impact force when contacting with the substrate, and for adjusting the adhesive features of bottom part, which is a bio-dry adhesive feature material. After the construction of physical prototype, let's say something about locomotion control. The locomotion strategy was designed firstly from the extraction of the attachment and detachment movement of gecko, from the motion capture of gecko movement using high-speed camera. The 3 periods in stem phase of gecko's locomotion could be distinguished and defined. They are attaching period, holding period, and detaching period. By rotating the leg, the foot shows spatial contacting posture in different periods. Some key points are extracted and applied to the locomotion of Gecko-inspired robot. Considering the locomotion adaptability and further development of bio-inspired control framework, the CPT-based control method was used here. For helping the robot to finish complex adhesive movements in feet, the RBF neural network was added here. The trained CPT-based neural network processed the key points in adhesive movement and was applied to the hardware of Gecko-inspired robot. Till now, the Gecko-inspired robot system was accomplished. To test the locomotion and body height adaptability of Gecko-inspired robot, the experiments for obstacle overcoming was set here. The infrared sensors installed on the front and tail position of the robot were adopted to detect the obstacle. When the front sensor detects the obstacle, the robot will lift the body up to overcome it. And when the tail sensor detects it, the robot will depress the body to recover to a normal working height. The ground experiment exhibits The robot was overcoming the obstacle with 6 cm, which is nearly equal to the robot's body height. The slope experiment displays the robot can overcome obstacles and utilize the adhesive ability. The detailed experimental results of obstacle overcoming experiments include the angular position and footfall signal, which are shown on the left figures. From the analysis of real gecko, a gecko-inspired robot with specific function was built. The experiment result shows that the primary requirements of design purpose was satisfied, such as the adhesive features and body height adaptability. The further work will focus on the improvement of control neural network, which can provide the robot with more stability and steep slope climbing ability by optimizing adhesive force on the feet. That's all for the presentation. Thank you for listening.